Today, I'm going to show you 3 methods for making full screen masks in Unreal and Unity, and then I'll show you 2 different things that you can do with them. Let's go! So, we're doing this series of videos on post-processing effects, and last week I showed you how to set up this shader to do simple screen warping. If you didn't see last week's video, click this link right here and go back and watch it so you'll know how to get this effect set up. We're going to be building off of it today. Before we get too far into creating masks, there's one change that I want to make to last week's shader. Can you see how the screen looks stretched here at the edge and here along the bottom? This is a pretty common problem with post-processing effects, and I've even seen it in several shipped games. The reason that it's happening is because the effect is warping the screen up and to the left, and so we see it on the right and on the bottom. On these edges, the post-processing effect is asking for pixels that don't exist because they're off the screen. So the best it can do is duplicate existing pixels along the edge. Let's take a closer look at the shader and see if we can figure out what's going on. So let's focus on these 2 texture sample nodes here. We're sampling 2 textures and then using the red channel and the green channel here. So our range coming out of these texture samples is between 0 and 1. And then we're adding them together right here. And so our total range, once we've added these together, is between 0 and 2. And then what we do is we add them to our texture coordinates. And that's what's causing this offset that goes up and to the left, because we're only offsetting in one direction. So we have a range that goes from 0 to 2, but what we really want is a range that goes from -1 to 1. And that's easy enough to fix. All we have to do is replace this saturation node here with a subtract, and we'll take our range that goes from 0 to 2 and subtract 1 from it. And once we do that, we'll get a range that goes from -1 to 1. So I'll save the shader, it'll reload here, and now you can see, boom, our problem is solved. Pretty cool. Okay, now because of this offset effect, we will still occasionally get a little bit of stretching, and that's one of the reasons why I'm showing you how to make these full screen masks today. So let's get right into that. I'm going to show you how to make 3 different kinds of masks and talk a little bit about what they can be used for. And then in future videos, we're going to apply these 3 different types to create all kinds of effects. All right, the first kind of mask that we're going to make is a square mask. So I'm going to start off with a texture coordinate node, and I'm going to multiply my texture coordinates by the inverse of themselves. So I'm going to add this multiply, and then I'm going to add a 1 minus. Actually, before that, I'm going to add a value in here that allows us to control the effect. So I'm just going to give us a constant value of 50. I'm going to multiply our texture coordinates by 50, and I'm going to multiply the inverse of the texture coordinates by 50 as well. So this is the value that I'm going to be able to use to control how much of a border around the edge I'm getting. So I'm going to add a couple of saturate nodes here, just to make sure that after I multiply by 50, we're not going to a value higher than 1. All right, so I'm going to saturate both of these, and then finally I'm going to multiply them together. Then I'm going to split them apart again so that I get the U coordinate and the V coordinate separately. So to do that, I need to add a component mask. The first one is going to be the red channel, and the second one is going to be the green channel. And then I'm going to multiply the 2 of these together, and finally I'm going to saturate the result. All right, let's plug this mask into our root and see what we get. So I'm going to wire my saturate into the output emissive color here, and we'll save it. And let's take a look at our scene. So I don't know if you can see this, but there's this black border around the edge of the scene. And if I come down here to my value of 50, let's drop this down to 10 just to make this effect a little bit more obvious. Okay, so here you can see I've got this black border. So from the edge, it's black, and then it comes in here and it gets to the value of white about right there. And I can control how this effect works by multiplying it by this hard-coded value here. So the lower my value is, the further into the center of the screen that I'm getting. And the higher my value is, the further away from the center my black borders are getting pushed until I get to the edge. So if I want to mask off just the very edge, I can use a value like 50 on my mask. And now I've got this black that's just right around the edges of the screen. Well, what can I do with this? If I take my mask and I allow it to control how much offset is happening, then I can tell my my warping effect here to not do any offsetting right around the edges of the screen. So here's the mask that I created, and here's the value that controls how much warping I'm doing. So if I take this value of how much warping I'm doing and I multiply it by my mask, now I'm going to get 0 warping at the edges, and then it's going to go to the normal amount of warping everywhere else. So let's go ahead and save this and take a look at our result. So before, I don't know if you remember, but we were getting a little bit of stretching here around the edges, and now we're not getting any stretching because we're doing the full amount of warping here in the middle of the screen, but once we get to the edges, we're using that edge mask to turn our warping off, so the closer we get to that edge, the less warping we're doing. All right, pretty cool. That's how you make a square mask. Let's take one more look at that. There's our square mask shader. Now, what if we want to make the edges of this mask a little bit more round? So we're gonna take a look at how to make a rounded full screen mask next. And this one is pretty similar to the square one, but there are some subtle differences. So let's just go ahead and jump in and make this. We'll start off with our UV coordinates again, and we'll add a multiply, and we're gonna multiply our UV coordinates by the inverse of our UV coordinates. So we'll add a 1 minus node and wire that into our multiply. Next, we'll split out our individual channels, and so I'm going to add a component mask, and I need one for red, and I need one for green. Then we're going to multiply them together, and then I'm going to multiply it by itself. And the reason that I'm doing this is because it's cheaper than raising it to a power of 2, but this is another way of getting some more contrast. One thing that you might be wondering is, why are you using all of these math nodes to make a mask when you could just sample a texture that was shaped like the kind of frame you wanted around the edges of the screen? And the answer to that is the graphics hardware can do this small amount of math much faster than it can sample a texture. And so it's actually more efficient to just do a little bit of math than to do a texture lookup. All right, the next thing that I need to do is add another multiply node in here. And in this case, we're going to multiply it by a very large number. I'm going to multiply it by a value of 80,000 because of all these multiplies that we're doing, we've darkened our mask down quite a bit. So now I'm going to brighten it up by multiplying by 80,000. Then we need to add another saturate here right at the end just to make sure that we don't go higher than 1. Okay, so this is our rounded mask, and it is pretty similar to our square mask with some key differences that allow us to get some rounded edges. Let's move our square mask out of the way for now, and let's plug in our rounded mask just to take a look at what this one looks like. You can see it here in the preview. It looks pretty cool, but let's look at it full screen. It looks kind of like a cathode ray tube, one of those old computer monitors or TV sets with the way that it's shaped here. And you can use this constant value of 80,000 to control the shape. So if I reduce it down to like 10,000, we can get something that's a little bit further in. The lower the number gets, the closer to the center we'll get our mask. Let's go down to something like maybe 500, and we'll end up with a really small circle that fades very slowly out to the edges. So the higher this number goes, the further toward the edges we're pushing the mask. But because of the way that we've configured our nodes here, we're getting nice rounded edges on our mask. So that's pretty cool. So we could use the square version of our mask, or we could use the rounded version of our mask to mask out that warping effect. And we can do all kinds of other things with these masks as well. And so we're going to get into that in future videos. All right, I do have one more method to show you. After I show this method, then we're going to switch over to Unity, and I'll show you how to make the masks there as well. So this method is based on the distance from the center. So let's start out by taking our texture coordinate node, and we're gonna use our texture coordinates to find the center of the screen. So the texture coordinates go from 0, 0 in the very top left corner to 1, 1 in the bottom right. So if we want to find the center, what we need to do is subtract a value of 0.5, 0.5. So I'm going to hold down the 2 key and click to add a vector 2 here. And we're going to give it a value of 0.5, 0.5 and subtract that from our texture coordinates. So this will give us the center of the screen. Now, if I add a length node, going to do a vector length, and this is a vec2, so I need to plug it into there and disconnect it from vec3. This will tell me how far away from the center I am. So right in the center, I'll get a black value, and then the further away that I get from the center of the screen, the brighter my value is going to be. So let's go ahead and plug this into our root and see what we get. And what you're going to see is that I've got this mask that's going from black in the center to white on the edges. And now we just need to tweak some things to adjust it a little bit. So let's go ahead and do that. The first thing that I can do is I can add a multiply right here to control how big the UV coordinates are on the screen. So I can, once I've found the center, I can scale up or down from the center. Here I'm just going to hold down 1 and click to add constant float parameter, and I can plug this in, and if we add a value of like say 0.66, now I can scale these so that I'm pushing the dark part of the circle further out toward the edge. So that's one way of controlling the effect. Let's also go ahead and add a saturate here to make sure that we don't go outside of our 0 to 1 range. And now I'm going to add a power node, and this is going to allow me to control the fall off or the contrast of the effect. So I'll just go ahead and add another constant here. We'll give this a constant value of say 1.5. And now I want to invert the effect, and so I'm going to add a 1 minus. And let's go ahead and plug this in and see what we're getting, just as kind of an intermediate step. Now you can see I've pushed my effect out more toward the edges, and I've kind of brightened it up. All right, for one last thing, I'm just going to add an add node here and add a small value to brighten it up even more. So we're going to add a value of 0.05 and then saturate our final result. And now I'm going to plug this into our final our root node here, and we'll get to see a preview of what our effect looks like. So let me minimize this, and we'll take a look at what our effect looks like on the screen. Okay, so you can see with those adjustments that I made, I've got some subtle darkening happening here around the edges of the screen. This is the kind of mask that we can use to achieve a vignette effect. So what I can do is I can tweak my values for the size of it. Set this to 0.89, for example. This will pull in the edges, give me a little bit more vignette. And I can adjust the fall off with this value. And then I can adjust the overall brightness with this value. And so now what I can do with my vignette is I can take my scene sample and multiply my mask by that. And what this is going to do is it'll create a vignette which is kind of a subtle darkening around the edges of my scene, which is something that a lot of camera lenses do, and it makes the scene feel just a little bit more natural, as if it were being filmed through a real camera lens, which is pretty cool. All right, let's do a quick review and then we'll jump over to Unity. So I showed you how to create this mask here, which creates squared off edges. I showed you how to create this mask here, which creates rounded edges. And then I showed you how to create this mask here, which is nice and soft and is really good for vignettes. So these two kinds of masks are really good if you want black, perfect black right around the edges of your screen. So this is kind of focused on the edges but square. This one's focused on the edges but round. And then this one is more focused on the center. So it's going to guarantee you get white in the center and then a nice smooth fall off from there in all directions. So pretty cool. 3 methods for creating full screen masks that now we're going to take forward into the future. And I'll show you in the next coming weeks in future videos how to use these masks to achieve various additional post-processing effects. All right, cool. Let's switch over to Unity and I'll show you how to make these there. All right, here we are in Unity, and you can see that just like we were getting in Unreal, we're also getting stretching around the sides of the screen here in Unity on our warping shader. So we've got stretching here at the top and stretching here along the side. And we can fix that by adjusting our range to go from -1 to 1 instead of 0 to 2. So I'm just going to take the values that I've added together coming out of our distortion textures and subtract 1. And once I do that and hit save, now my stretching along the outsides of the screen is gone. There is occasionally a little bit of stretching, and you can see that right here along the edge and up here. And that's what we're going to use the masks to take a look at and fix today. So let's jump right in and create our masks. The first one that we're going to create is a square mask. And I need to start off with my screen position data. And I only need the X and the Y. So I'm going to add a swizzle node here and just type X and Y in my swizzle node so I can isolate the U and the V coordinates of my screen position. And now I want to multiply these by a value that I'm going to use to control the strength of the effect. So I'm going to add a float here, and we're going to give this a hard-coded value of 50. And we're going to multiply our UV coordinates by that. Now we're going to take the inverse of our UV coordinates. So I'm going to add a 1 minus node. And we're going to multiply that by 50 as well. So I need to add a new multiply and wire in my value of 50 here. And there we go. Now that that's done, I need to saturate both of these just to make sure that they don't go over a value of 1. So there's my saturate node for that side, and I can just copy paste it and make it for this side. Cool. Now I'm going to take the two of these and multiply them together. And you can kind of see what I'm getting here. You can see that I've got red along the upper border here and green along the sides. And so now that I've got that border going, what I can do is split this out into its red and green channels and then combine the two borders together just by using a multiply node. So now I've taken the value on the sides and the value in the top and multiplied them together. So there you can see the beginnings of the effect that we're creating. And so all that I have to do to finish that off is just add a final saturate node. And we've got a nice square edge mask. So let's go ahead and wire this into our master stack here. And we'll hit save and take a look at our results. So here you can see right along the borders, I'm getting this nice square mask at the top and at the sides. And I can control how much of this effect gets applied if I just come over here and change this value of 50. So if I set it to a value of 10, for example, the sides will get much longer. If I set it to a value of 5, I'll pull this mask in even further. But you can see how the mask is mostly just square along the edges of the screen. And then I can control how far I want to push it toward the edges of the screen by controlling this value here. All right, so that's our square mask. And just like we did in Unreal, if I take the result of this mask and come up here to where I'm controlling how much of my effect, my warping effect I'm applying. So I'm applying this value of 0.03. Let's just add a hard-coded float value here of 0.03 to represent that. And then if we multiply that by our mask, we can tell it we don't want any warping along the edges. We only want it to show up in the center because the warping at the edges is what's causing that pixel stretching. So I'm able to mask that out by doing this. We'll multiply our 0.03 by our edge mask and then plug that into our warping effect and reconnect our warping effect here and hit save. And now we're getting warping everywhere but right along the very edges. And this should prevent us from ever getting that stretching that we were seeing before. Pretty cool. So that's one potential use of this square mask that we just created. Let's go ahead and jump in and make the rounded edge mask instead. Just like I said when we were working on the Unreal version, this is very similar to the square mask with just a couple of key differences. So let's start off with our screen position and our squizzle node here to isolate the U and the V coordinates. We'll add a 1- node to get the inverse of the coordinates. Basically what we're doing here is isolating the top and the right and the bottom and the left. So we'll multiply the regular UV coordinates by the inverse coordinates. And then once we've got that done, we'll split these out so that we can access the individual channels. And I just want to take the red channel and multiply it by the blue channel. So here you can see I've got the edges falling off here and here. And then if I take a look at the green channel, this is the top and the bottom. And if I multiply the two of these together, you can see I've got a mask where I'm multiplying, or I'm masking off the top and the bottom and the sides as well. All right, let's just kind of clean things up here and move right along. The next thing that I want to do is multiply these values by themselves. So I'm basically raising this to a power of 2 with a double multiply here. And then once that I do that, now I need to multiply it by a really large number. So I'm going to add a new multiply here. And we're going to multiply this by 80,000 just because we had darkened it quite a bit. And now you can see that was kind of cool when I typed that number in again. I'm going to do it again. So here's 8, 0, 0, 0. You can see the more zeros I press, the closer to the edge it's pushing my mask. So that's a pretty cool way to take a look at it. And then finally, we're going to add a saturate here at the end just to make sure that we don't go outside of our 0 to 1 range. And now we've got our rounded mask. So let's go ahead and connect this into our master stack and take a look at what it looks like in the scene. There we go. So I've got that nice cathode ray tube effect where I've got my curved edges and kind of a smooth fall off. And if I want to bring the mask in toward the center, I can just change whatever value I've typed in here. If I type value of 1,000, for example, I can get a mask that comes much closer in toward the center than it was before. But I tend to kind of like a value of about 80,000 because it just isolates the edges and pretty much leaves the center alone. All right, that is our rounded edges mask. The last one that we're going to look at today is our smooth fall off mask, the one that we can use for a vignette. So let's go ahead and make that. Again, I'm going to take screen position with our swizzle node, and I'm going to multiply this. So my screen position, if in Unity I can get the center position like this, I don't have to subtract 0.5. I can just tell it, hey, give me the screen position with the origin being in the center. So that's a nice little feature. Now I'm going to add another multiply, and we'll multiply this by 0.66 and 0.66, and this is going to control how far in toward the center our effect goes. And once I've done that, now I need to measure the length or how far away from the center I am. So I'm just going to add a length node here. Now you can see I'm getting a nice length value where right in the center I get a value of 0, but then the further away from the center, the brighter the color or the brighter the mask gets. All right, I'm just going to add a saturate to make sure that we don't go outside the 0 to 1 range. Now we can add a power node, which we can use to adjust the fall off of my curve. So I'm going to set it to a power of 1.5, but you can see if I set it to a power of 2 or a power of 3, you can see instantly what that power node is doing. And this is a value you can tweak if you want to change the type of effect you're getting. So let's leave it at a power of 1.5. Then we'll invert the effect by adding a 1 minus, and this is going to make it white in the center and then darker around the edges. And finally, just to top it all off, we're going to do another add node. I'm just going to add a very small value to make it just a little bit lighter in those corners. We're going to add a value of 0.05 and then add a saturate node to clamp our range between 0 and 1. All right, so there we have it. That's our kind of smooth fall off distance from the center method of calculating the mask. And now all we have to do is take that value and plug it into our master stack, and we can take a look at our results. So you can see that I've got this nice white value here in the center, and then it falls off and gets darker toward the edges. And if I want to use this as a vignette, I can just take my scene color node here and multiply that color by my nice smooth mask. And the end result that I get is my scene with a vignette effect around the edges. So I'll just save that and we can take a look. It's kind of subtle here. Maybe we can adjust it just a little bit. All right, I tweaked my parameters a little bit, and I think you can see it a little bit better now. You can see down into the corner here, it's kind of dark, and this is a vignette effect that kind of simulates what a camera lens would do, darker around the edges of the lens and brighter in the middle. So that's one pretty good use for our distance-based mask. All right, so today we learned how to do a square edge mask, a round edge mask, and a distance mask. And like I said, in future videos, I'm going to go ahead and show you how to apply these in all kinds of different effects. If you have some ideas for post-processing effects you'd like to see, be sure to post those down in the comments. Hey, I really appreciated all the comments that I got last week. Some really great ideas that I've got on my list, and I hear you, and they're coming. So we're going to talk about a lot of those things that you guys posted. I appreciate it. Thanks a lot for watching today, and have a great week.